In this video, we're going to focus on memorizing the polyatomic ions. Now, you need to commit this to memory because this information will be useful for the remainder of your chemistry course. You need it to write formulas of chemical compounds, to balance equations. You need to know the charges as well. And if you're first learning polyatomic ions, you may think it's not important, but later on in chemistry, you'll see that it is important. So you might as well just learn it now. The first one we're going to talk about is NO3 minus. In addition, we're going to talk about NO2 minus and N3 minus. Do you know the names of these three ions? The first two are polyatomic ions because they're ions that are composed of many atoms. The third one is a monoatomic ion. It's an ion that's composed of one particle, one atom. The first one is called nitrate. The second is known as nitrite. So one thing you need to be familiar with is that 8 has one more oxygen than I. Anytime you see 8 or I, it's a polyatomic ion that contains oxygen. The last one is known as nitride. If you see the end in IDE, typically it's a monoatomic ion. Not always though, but usually it lacks oxygen for the most part. Now what about these three? SO4 2 minus, SO3 2 minus, and S2 minus. Can you guess what the names of these three ions are? So the first one is a polyatomic ion, and its name is sulfates. So if SO4 2 minus is sulfate, what is the name of SO3 2 minus? Notice that it has one less oxygen, so it's going to be called sulfite. 8 always has one more oxygen than I. Now the last one doesn't have an oxygen, it's a monoatomic ion. So this one is called sulfide. It has the suffix IDE. Here's some other examples that you need to know. PO4, PO3, and P. All three of these have a 3 minus charge. So what is the name of PO4 3 minus, if you had to guess? PO4 3 minus is known as phosphate. PO3 3 minus is called phosphite. As you can see, even in this case, 8 still has one more oxygen than 8. P3 minus is a monoatomic ion. It doesn't have oxygen, so it's not going to have the end in "ite" or 8. It's going to have the end in "ide." So this is going to be called phosphide. So hopefully you see this pattern at this point, because it's very useful to help you to know the name of an ion, be it a monatomic ion or a polyatomic ion. Now what about these 5? Cl minus, ClO minus, ClO2 minus, ClO3 minus, and ClO4 minus. What are the names of these 5 ions? So the first one is a monoatomic ion, so it's going to have the end in IDE. This is called chloride. Now what about the other 4? They're polyatomic ions. They have many atoms. I'll give you ClO3. ClO3 minus is known as chlorate. So, from this one, can you determine the rest? Well, you know 8 has one less oxygen than 8, so ClO2 minus must be chlorite. But now, how do we name something that has one more oxygen than 8? What you do is you add a per in front of it. So this is going to be called perchlorate. Perchlorate is ClO4 minus. And if you have something that's one less oxygen than 8, it's going to be hypochlorite. So you add the prefix hypo in front of it. So knowing that, Go ahead and name these 5 ions: Br minus, BrO minus, BrO2 minus, BrO3 minus, and this one as well. So pause the video and see if you can name all 5 of these correctly. So let's start with the first one. The first one is called bromide, very similar to chloride. The next one is known as hypobromite. BrO2 minus is bromite, and BrO3 minus is called bromate. BrO4 minus, perbromate, very similar to perchlorate. So for the halogens, it follows this trend. So now that you've worked on the other 2 lists, go ahead and try to name these 5. So you should be a master at this point. So what are the names of these 5 ions? The first one is known as iodide, very similar to chloride or bromide. The next one is called hypoiodite. Very similar to hypochlorite. And this one is just called iodite. IO3 minus is known as iodate, and IO4 minus is iodate. So now let's move away from the halogens, and now let's talk about something else. How would you name these 2 polyatomic ions, CO3 2 minus and HCO3 minus? CO3 2 minus is known as carbonate. HCO3 minus is called hydrogen carbonate because you have a hydrogen in front of it. Sometimes this could be referred to as bicarbonate. So just keep that in mind. If you see bicarbonate, it's the same as hydrogen carbonate. So based on that example, what are the names of these 2 ions? So you know that SO4 2 minus is called sulfate. So if that's the case, what is the name of HSO4 minus? Like hydrogen carbonate, this is going to be called hydrogen sulfate. Or you can call it bisulfite. So if HSO4 minus is hydrogen sulfate, then what is the name of HSO3 minus? This is called hydrogen sulfite because it has 1 less oxygen. It always has 1 less oxygen than 8. You can also call it bisulfite. Now what about this one? PO4 3 minus, HPO4 2 minus, and H2PO4 minus. We know that PO4 3 minus is called phosphate. So what is HPO4 2 minus? This is known as hydrogen phosphate. Now if that's the case, what's H2PO4 minus? This is known as dihydrogen phosphate. Di means 2 in chemistry, so dihydrogen indicates that you have 2 hydrogen atoms attached to a phosphate group. Every time you add a hydrogen, notice that the charge, it increases by 1, because the charge of a hydrogen ion is +1. Go ahead and name these 3 ions. So what is the name of PO3 3-? If PO4 3- is phosphate, PO3 3- is phosphite. It has one less oxygen. Now if we add a hydrogen to it, this is going to be called hydrogen phosphite. Now if we have two hydrogens, then it's called dihydrogen phosphite. Now, what are some other names that we need to go over? Here's another one. What is OH- called? OH- is known as hydroxide. So, commit that to memory. What I like to think of is we're adding a hydrogen to oxide. O2- is oxide. So I combine them and think of the word hydroxide. Now what about the NH4+ ion? What is the name for this polyatomic ion? NH4+ is known as the ammonium ion. Now don't confuse that with NH3, which is not an ion. NH3 is ammonia. So make sure you know the difference. Now what about these two ions? C2H3O2-, which is a common one, and also C2O4 2-. And don't confuse it with CO3 2-. You know CO3 is carbonate. C2H3O2- is called acetate. And C2O4 2- is known as oxalate. Now what about these? CrO4 2- and Cr2O7 2-. So what are the names of those ions? CrO4 2- is known as chromate. Cr2O7 2- is called dichromate. There's two chromium atoms in this polyatomic ion. Now what about MnO4-? This is another common one that you need to commit to memory. This is known as permanganate. So make sure you know that one too. Now what about S2-, S2 2-, and S2O3 2-? What are the names of these ions? Now we mentioned that S2- is known as sulfide. We talked about that before. It has the end in IDE. It doesn't have any oxygens attached to it. The next one is a polyatomic ion without any oxygens. This is known as disulfide because there's two sulfur atoms in this ion. S2O3 2- is a polyatomic ion with oxygen, so it's going to have ite or ate. This one is called thiosulfate. If you hear the word thio, it's associated with sulfur. So it's thiosulfate. Now what about these two? Cn- and SCn-. Cn- is known as cyanide. SCn- is called thiocyanate. Now this one's a polyatomic ion with an IDE ending, so there are exceptions, so watch out for that one. Now what are the names of O2-, O2 2-, and O2-1? So what are the names of these ions? O2- is known as oxide. This is the common form of oxygen as an ion. O2 2- is known as peroxide. You've seen hydrogen peroxide in your bathroom. O2-1 is known as superoxide. So oxygen can be in these different forms. Now what is the name of this ion? N3 minus. And let's not confuse it with N3 minus. So N3 minus is a monoatomic ion. It's composed of one particle with a -3 charge. This is known as nitride. So to draw the Lewis structure, it's a nitrogen with 8 valence electrons. It has 5 of its original valence electrons, but it gained 3 because of the -3 charge. So that's nitride. This is known as azide. Azide is composed of 3 nitrogen atoms. It looks like this. The nitrogen in the middle has a positive formal charge, and the ones at the end carry a negative formal charge. If you add up +1, -1, and -1, you get an overall net -1 charge. So that's the difference between N3 minus 1 and N3 minus. So this is azide and that's nitride. Now what about this one, BO3 3 minus? What is the name of that ion? And let's also go over H3O plus. BO3 3 minus is known as borate. H3O plus is hydronium. So those are some polyatomic ions that you may want to commit to memory. And another unusual one that you may see in biochemistry or even in biology is P2O7 4 minus. This is known as pyrophosphate. Now let's go ahead and review some of the polyatomic ions that we went over. You can take this as a quiz. So I'm going to give you the name and I want you to write the formula of the polyatomic ion. So let's start with sulfate. What is the polyatomic ion that corresponds to sulfate, sulfite, and sulfide? So feel free to pause the video as you figure this out. Sulfate is SO4 with a -2 charge. Sulfite, SO3 2 minus, and sulfide, S2 minus. Write the formulas of these polyatomic ions. Chlorite, hydroxide, cyanide, nitrate, and acetate. So what's the formula for chlorite? Chlorite is ClO2 with a -1 charge. Hydroxide is OH minus, cyanide Cn minus, nitrate NO3 minus, acetate C2H3O2 minus. Now what about these? Phosphite, carbonate, nitride, ammonium, and let's say hypochlorite. Go ahead and name these 5 ions. So what is the formula of phosphite? Phosphite is PO3 with a 3 minus charge. What about carbonate? Carbonate is CO3 2 minus. Nitride N3 minus, and ammonium NH4 plus. Hypochlorite, that's ClO minus. So here's the next round of questions. Bisulfite, hydrogen carbonate, permanganate, oxide, iodide, and let's say thiosulfate. go ahead and write the formulas for these ions. So what's the formula for bisulfate? Bisulfate contains one hydrogen, so it's at HSO4 minus. Sulfate is SO4 2 minus, and if you add H plus, 1 plus negative 2 will give you a net charge of minus 1. Hydrogen carbonate. So basically you're adding H plus for hydrogen and carbonate combine. These two would add up to HCO3 with a negative 1 charge. Permanganate is MnO4 minus. Oxide is an oxygen with a minus 2 charge. Iodide is I minus 1. Thiosulfate is S2O3 2 minus. Try these. Azide. Thiocyanate. Oxalate. Chromate. Dichromate. Peroxide. Bromate. And phosphide. So take a minute and pause the video and see if you remember the formulas that correspond to these names. So let's start with azide. Azide is a polyatomic ion that contains 3 nitrogen atoms with a net negative 1 charge. Now next we have thiocyanate. Now you know there's a cyanide in it. When you hear the word thio, think of sulfur. So this is SCN minus. Oxalate. Oxalate is a 2-carbon molecule with 4 oxygens. It's C2O4 with a negative 2 charge. Chromate has 1 chromium atom, but when you hear the word 8, that means it has some oxygen in it. Chromate is CrO4 2 minus. Dichromate has 2 chromium atoms. Dichromate is Cr2O7 with a negative 2 charge as well. Now what about peroxide? If you recall, peroxide is a polyatomic ion with 2 oxygen atoms and a charge of 2 minus. Bromate is a polyatomic ion with bromine, 3 oxygens, and a negative charge. And finally we have phosphide, which is just a monoatomic ion due to the IDE ending, so it's P3 minus. So here's some more examples. Iodate, chlorate, bromide, iodide, bromite, superoxide, hydrogen phosphite, and borate. So go ahead and try these problems. Now what is the polyatomic ion? What's the formula for periodate? So when you're dealing with the halogens, when you hear the word per, think of 4 oxygens. Hypo tells you have 1 oxygen. If it's just ite, 2. 8, 3. Per with 8, 4. So this is going to be iO4 with a minus charge. Chlorate has 3 oxygens. So it's ClO3 minus. Bromide with the IDE ending doesn't contain oxygen. So it's simply Br minus 1. All of the halogens, as you can see, they have the same charge, negative 1. Iodide is going to have just 2 oxygens, IO2 minus. Hypo with ite is going to have 1 oxygen, so it's BRO minus 1. Superoxide contains 2 oxygens with a minus 1 charge. Hydrogen phosphite So we have a hydrogen and the phosphite ion. If we put those two together, it's simply going to be HPO3, and we add the charges. +1 and -3 adds up to -2. Borate, it's simply BO3 with a -3 charge. So here are some more examples. Let's try bromite, chloride, iodate, perbromate, hypoiodite, dihydrogen, phosphate, hydronium, and disulfide. So go ahead and work on these examples. Write the formulas for each of these polyatomic ions. Now let's start with bromite. If it simply has the ITE ending and it's a halogen, it's going to have two oxygens. So this is BrO2 with a -1 charge. Chloride has the IDE ending, so it's a monoatomic ion. It's simply Cl-. Iodate, without the per, is going to have three oxygens. So this is IO3-. Perbromate, this one does have the per and the 8, so it's going to have four oxygens. BrO4-. Hypoiodide, with the prefix hypo and the suffix ite, it's going to have one oxygen, so IO-. Dihydrogen phosphate, so we're adding two hydrogens and a phosphate. So if we add +1 2 times, that's +2, and add that to -3, the net charge will be -1. So this is going to be H2PO4 -1. Hydronium is simply H3O+. Disulfide has two sulfurs and a -2 charge. It has the end in IDE, so it doesn't have any oxygen atoms attached to it. Now these are the last ones. Perchlorate, bisulfite, hydrogen phosphate, dihydrogen phosphite, and lastly, pyrophosphate. So let's start with perchlorate. Perchlorate is going to have four oxygens and a -1 charge. Bisulfite is H with SO3. Now SO3 has a -2 charge, H has a +1 charge. If you add them, you're going to get -1. Hydrogen phosphate, that's one hydrogen with a PO4 ion. So 1 plus -3, this is going to be -2. Dihydrogen phosphite. Phosphite has three oxygens. So it's H2 for dihydrogen, PO3, and the net charge will be -1. Pyrophosphate, you just got to know it. It's P2O7 with a charge of -4. And so that's it for this video. So now you know the most common polyatomic ions that you may be tested on.